Hello, in this video I want to show you how to create more efficient tile maps. So this is a pretty standard tile map right here, which you can use to create any shape you want up here for like a platforming game or whatever you're making. Um, this uses 48 tiles, and you can create any shape at all. But what if I told you you could create the exact same result with these 5 tiles? Well, that's exactly what I have right here. I have the same shape as up above, but drawn out of this tile 64, and when I run the program, you can see the results are identical. So how to do this? Well, let me show you. So um, you can probably see here we've got a bunch of different pieces of the sprite. We've got the top edge, a bottom edge, left edge, a right edge. These are inside corners, and then these are outside corners. So you can kind of see how we would begin to combine these together to create this end result. You can put the top edge here, left edge here. These outside corners can be used to make the edges rounded, and then these inside corners, you can see how on this tile you've got top inside corners that kind of let the grass go into the side a little bit. It kind of makes the tiles flow smoothly together. We've got the bottom inside corners too to make the rocks kind of look like they're continuing into the edges of the other tiles. So these 4 tiles can be spliced apart and then put back together to create the same result. Put over top this base tile. So I'll show you how the code for this works. First of all, I've got a function here called full that just returns whether a tile is that brown base tile number 64. It makes the code easier to read. In the draw loop here, I draw the map first, and then for each tile, loop through every tile, and then if that tile is full, then we need to draw something over top of it, right? I'll tell you what these left and right variables do later. Let's look at this first. So it says if not full, x minus 1y. So x minus 1y, that's its neighbor to the left. So if the neighboring tile to the left is not full, meaning it's one of these edge pieces here, then draw this sprite right here. So that is the left half of this sprite here. That's what that does. So then we just basically do the same for all the other pieces. We've got the right side, the ground tile, so that's the top edge, and the bottom edge as well. Then we've also got the inside corners here. So the reason this is inside an else statement is because if you look back at here, if we draw a left edge here, it wouldn't make sense to put inside corners here because we're already on the left side. It just doesn't make sense. But in a case like this, where there is no left edge to draw, then we would want to check the left side corner. So that's what this does. If it either draws the left edge or the left side inside corners. And same for the right side. It either draws the right edge or the right side inside corners. And then we get to where we're using the right and left variables. So you can see they're false by default. And then if we find a left edge, left is set to true. And if we find a right edge, right is set to true. And then down here, with the ground and the ceiling, if it's a top edge tile and it's a right edge tile, well then we know it must be a corner tile. So we draw the corner sprite. That's what that is. So that's how we draw the outside corners. It gives them this nice rounded edge kind of look. And that's basically the whole thing. We have 12 if statements for the 12 different pieces of the tiles. We overlay them all one on top of the other. And you can see it creates a very nice result. And you can see just how much space was saved. This is 48 tiles, this is only 5, so you've got so much more room if you use this technique for character animations, more environments, really anything you want to use. So hopefully that was helpful. Maybe you can use this in one of your projects. And that's all for me. See you later. Bye.